Hello students, so we will study force and pressure this chapter, and lecture 2 we will continue here. So types of forces, here we will continue. Now the force is very well known to us, but the different types of forces actually in our daily life we are seeing, but we are not noticing every types of the forces. So whenever you are just going through this lecture, at that time you can see that whatever the types of forces, and already you have just seen all the types of forces. Just now you have to define which one is the which type of force, right? So here, first thing, that is the contact. That point is very important. Whenever force this comes into our picture, whenever force that comes to our picture, at that time, first thing we have in our mind that I am just pushing something or I am just lifting something, right? Some object, and it has some mass, right? So here the contact is very important term. Contact is very important term. So a touch, it may be you are just throwing one ball, or it may be you just touched one balloon and it has just changed its position. So, okay. So this is the contact, right? That means we are in a touch with the object and we are just giving the or changing the condition of the object. It may be the object in a rest condition and we are moving it into the motion, we are moving it into the motion, or vice versa. Some object we have in motion, but what we are doing, we have to stop the movement of the object, like one ball you have, and at that time, if you have one ball here, at that time I want to stop the ball, and this is moving in the field, and I want to stop the ball. So what you are doing, you can use your leg or you can just catch it with your hand, right? That means what? If the movement is in this direction, you are giving the force in opposite direction so that it will resist the movement and it will come to the rest. It will come to the rest. And sometimes it will come to the rest suddenly, sometimes it will take some time, right? So the contact, whatever we have started this slide, that means I am touching the object or I am in contact with the object, like lifting anything, pulling, kicking, pushing. So this thing we are doing in our everyday life. Whenever we have to lift one book, right? That means what? You are in a contact with the book. Whenever you just pull the door, or you want to open the door, that's why you are just pulling the door. That means what? In your daily life, you have this thing, kicking the ball, you are just playing the football, or you are playing any football. At that time, you can see that you are using this procedure. You are pushing the door to open the door, or it may be just you just push one balloon also. Here in this picture, just a minute, I am taking the pointer. Okay. So here in this picture, we have this object, right? This is the object. And in this object, we have, this is a contact and this is another contact wall. Okay. And here the mg, this force, that is called the gravitational force, where this m is the mass of the object and g is the acceleration due to gravity. Acceleration due to gravity. Okay. So this acceleration is in this direction. So m into g, that is the total force whatever is applicable towards the ground. And there are two slanting surfaces here which also create some force here, that is contact force 1 and contact force 2. Okay, so this is the meaning of the contact. Next, the contact forces. Now muscular force or frictional force. Fine. So muscular force, you know that suppose you want to lift the book, and here this boy, okay, this boy, you can see that he wants to uplift, or he wants to push, not uplift, he wants to push this stone, very big stone, and you can see that he it might be the mass of the stone is so high that he cannot do that thing, but he is trying. Okay, so this is the pushing of the stone. Another thing, suppose one object is here and he wants to pull this one, drag this one, and here someone maybe he is carrying some box. Okay, so these are the muscular forces because they are using the muscles. They are using their muscles. Okay, now another thing, that is the frictional force. Suppose you have, this is the ground or floor, okay, and you have one object here. You have one object here. So this is the object and this one is the ground. Or you can say I have a floor here, and on the floor you have one object. Now you want to drag it. Okay, so if you want to drag it, at the interface or contact between this object and the floor, you can see there will be some frictional force acting on this. Frictional force acting on this. Now, whenever you are walking on a very smooth floor, you can see that the frictions are so, frictional forces, these are so small amounts that you can freely move from one side to another. But whenever you are just trying to move in a road, on a road, at that time you can see that the frictional forces are very high. That means the smoothness of the road is not like the floor, okay, like your marble floor or your tiles floor. So at that time you can see that your frictional force is very high. Another thing, this frictional force also you can see whenever you are using the car to stop, at that time also we are using frictional force. We are designing the tire structure, the surface of the tire, you can see that this is not so much smooth. This surface you can see that of the tire, this is some zigzag or some designs will be there. That gives some that avoids the smoothness of the tire surface, right? So here frictional force is also very important. That means for the frictional force, I need some contact, because the friction between the floor and object, or the friction between the road and the tire, like that. Another thing, another contact force, that is the muscular force. So here muscular force, that is also we need the contact with the object, right? I want to lift one object, I want to push one object, I want to pull one object, I want to carry the gift box. So everything that I need to use the muscular forces. Now here muscular forces, you can see that. So here this person just carrying one box, yeah, very highly attitude is there. After that he is trying to lift this block and it is very heavy and he has to keep it on the table. Another person you have here, that pulling a bucket of water here, right? Another person you can see here who is cycling. So that means in every cases you can see that they are using their muscles. So the muscular force they are using in every cases. For this one, Just a minute. It may be for this one, it may be for this one, or it may be for this one, right? So here you can see that, here you can see that, here you can see that the muscular forces they are using for to lift the heavy box, pulling a bucket of water, or paddling a cycle. Now this is very this child, you just see this child, he is trying to collect all the different colors balls, and this thing I know everyone in your childhood you have done this thing. So here he is trying to pick up all the balls, and it may be sometimes whenever you are entering into your room or your house, you just pushing the door, So all these actions are result of the muscular forces. He has to collect the ball with his hand, right? And he has to hold it. He is very small, but he has to hold it, and you can see from the picture that he is unable to hold all the balls, and if he is carrying one, then another one is dropping here. So he is trying, still he is trying. And this man pushing the door and again then entering into the house. Okay. So this here, that means muscular force we are using for these two cases. Now it is the contact force, because interaction between hand and ball you have here, and interaction between the door and the hand you have in this case, right? So these are the muscular force. Now the friction force or frictional force. Frictional force already I have discussed. Suppose I have a floor here. Tiles floor here, where your surface is very smooth, and above this we have another object. We have another object here. So you can see that the friction will be acting here. It might be the frictional force is less or high. So the frictional force, this may be high for rough surface like road, mountain, and frictional force is less in smooth surface. Another thing, the frictional force, that also depends on the, not only on the surface of this ground or the floor. It also depends on the object surface also. Suppose I have an object here like this, and I have an object like this. So here you can see that this surface, that is not smooth here, but in this object the surface is smooth here. So at that time also it is the same responsible thing for the frictional force. So frictional force, that is always acting on the moving objects, and the direction of this force is always opposite to the object in motion. Suppose one object is moving in this direction, the frictional force that will be acting in this direction. The frictional force that will be acting in this direction. And you have seen that whenever you are just taking one ball on the ground, after some time it will stop or it will slow down its speed. Why? Because on the ground you have the frictional force, and the frictional force that is acting in the opposite direction. So what it will do? It will resist the motion of the object. If you have the ball here, and it will resist the motion of the object. So this is the frictional force. Okay. So now here I have shown a lot of examples here. You can see one person who is cycling here, one bullock cart, and here you can see some objects, heavy objects they are taking, and this person she has to stop in the finishing line. Also, all of them they are using the muscular force. They are using the muscular force. Here the animals like bullocks, like horses, camels, donkeys, and elephants, all those animals which we are using them. Those animals we are using them to carry some heavy objects, right? Or for the movement of any object from here to there, we are using those animals. So those animals actually they are using their muscular forces to carry all those heavy objects, right? Here you can see that the camel is taking all the load of this van, right? So here that means it uses the muscular force. Also, this person she is using muscular force because she has to run, and that means what? She has to overcome whatever the frictional force she has in between this track and her foot. Okay, so here muscular forces we are using. Now force of friction, you can see that already I have discussed this thing, that a ball is rolling on the ground, gradually slows down or comes to rest due to the friction, force of friction, right? And if we stop paddling a bicycle, also you can see that after certain distance it will move certain distance, fine. It will slow down. After that, after certain time you can see that yes, it has stopped, right? So this is due to the friction. It will stop due to the friction. Okay. So and this ball also it slows down due to the friction, because here this is not a smooth surface. This is not a smooth surface. Now the frictional force, as I have told you, whenever you are applying the force in this direction, at that time frictional force will be in the opposite direction. Here this person, what he is doing, he is just trying to drag this heavy object towards himself, right? So this is and here you can see that he is sliding this up one track, right? And here this track also offers some frictions, and due to this frictional force, these two are in contact. This surface, the bottom surface of this block and this track also. So this, in between these two, we have the contact, and this is contact force. But here we are saying that yes, this is the frictional force which resists the object or the block to move in towards the man side. Okay, so this is the frictional force. Now non-contact forces. So till now whatever we have discussed, muscular force, also the frictional force, those are contact forces, because in every case we have to touch or we have to use any muscles of our body, and we have to touch the ground, or the object it has to touch the ground or floor, right? That means there should be contact in between these two objects. But here non-contact forces we are now going to study. Now forces that do not need a contact, that is the non-contact force. One thing you can see that this person, due to the gravitational force, here due to this gravitational force, it may be he will fall downward. And sometimes you can see that if you are using the comb, after certain time it has some charges here, so that it will attract some papers here. That is the electrostatic force. And this one is the magnetic force. Magnets, you can see that whenever you just keeping the magnet that is very close proximity with the nails, that is made up of iron, at that time you can see that it will attract the nail. That means it will attract the iron. Okay. So this is the magnetic force. Now here another thing, that is the net force. Now if we are applying the force here, suppose you are here and I am here. Okay. You are applying some force F1 and F2. Both of us, we are applying some force. So this will be F1 minus F2. The resultant force, that is effective force, that is F1 minus F2. Suppose I am using 5 Newton and you are just giving 2 Newton. So here 5 Newton minus 2 Newton, that is the 3 Newton of the force. Net force will be 3 Newton, right? So this will be the block where from this direction, I am applying 5 Newton, and from this direction I am applying 2 Newton. It's magnetic force. So we have seen in the earlier picture, that is magnetic force. We have seen here South pole and North pole is there. So if we place a point charge Q in the presence of both magnetic fields, now first thing, I have a charge point, that is Q, right? Point charge, that is Q. And there is some magnet. If you have some magnet here, you can see that some magnetic field will be there. Like, I'm just giving one example. You have the pond surface, you have the water surface on the pond. Fine. Now, suppose this is the water surface of the pond. You are throwing one stone here. What you can see, some wave will be there. Yes or no? Some wavy nature. You can see here. That thing, similar thing will be there for the magnet. If you are keeping the magnet in place of this stone, at that time you can see that there is some magnetic field around this magnet. So if I am keeping one point charge means any charge, if you are keeping some electrostatic charge and you have some magnetic field here, at that time you can see that what will be the effect on this charge. So here the magnetic field, that is BR, this is the magnetic field, and electric field due to the electric charge Q. This one is the magnitude of electric field. So Q is the charge and this is magnitude. Okay. So now we'll see what happens. The magnetic force, that will be your F, that is the magnetic force, and ER, that is the electric field, BR, that is the magnetic field. Obviously both are magnitude. Okay, so mathematically we can write down that F, that equals to Q into, where Q is the 1.6 into 10 to the power minus 19. Okay, whatever the Q you are keeping here, ER plus V into BR. Okay, so the magnitude of the magnetic force, it depends on how much charge is in how much motion in each of the objects and how far apart they are, right? So how much motion you have, that is also depend. Now this equation is called Lorentz equation or Lorentz force. And according to the scientist's name, this is the Lorentz force. This force is the, sometimes we are calling, this is the Lorentz force. So, and here it is the combination of electric and magnetic force on a point charge due to electromagnetic field. So what is Lorentz force? That is the Lorentz force is the combination of electric and magnetic force on a point charge due to electromagnetic fields. Now the interaction between the electric field and the magnetic field, it has some features. So first we can see that the magnetic force that depends upon the charge of the particle, because here F, in this equation we have the first term, that is the Q. So that means what? The magnetic force that depends on this charge, okay, in this you can see that F equals to this Q. That means this depends on the magnetic force that depends on the charge of the particle. Then we have, it depends on the electric field. Then it depends on the velocity of the particle. And it depends on the magnitude of the magnetic field. Okay. So this force that depends on the charge Q and your ER, that is the electric field, this velocity V, that is the velocity of charge particle. Velocity of charge particle, Q is the charge, or I can say number of charge, ER, that is the electric field, and BR, that is the magnitude of magnetic field. So the magnetic force that is calculated by the cross product of velocity and the magnetic field. So the resultant force is thus perpendicular to the direction of the velocity and the magnetic field, and the direction of the magnetic field is predicted by the right hand thumb rule. And here total magnetic force is 0. We are assuming this only for the case where we have some static charges. Now some questions here. Magnetic force is caused by the motion of charges. Magnetic force, already we have discussed here, magnetic force that depends on the, just a minute, I am just changing the color. So magnetic force that depends on, that is the Q, ER plus V, where this is the velocity. And this velocity means motion of the charge, velocity of the particle or charge. Sorry. BR. So here, this is the velocity, and this velocity, this V is the velocity of charge. That means this is the motion of the charge. So yes, it is true. Now, electric as well as magnetic force exists among moving electric charges. Yes, obviously, it will be there. What is the unit of magnetic field? Tesla. Please remember this thing. Now the electrostatic force. Electrostatic force, this is the force which exerted by a charged body on another charged or uncharged body. Right? So here, suppose I have, just a minute, I have to change the color. Okay. Suppose I have some charge that is positive. And there is some object where the surface, it has some positive charge. Another object you have that has some negative charge. So they will attract each other. Similar thing, we are doing something like a plastic straw that is charged by rubbing with a paper attracts a suspended plastic straw. So this is a plastic straw, and here we are this plastic straw. This is the plastic straw, and this we are charging this one by rubbing with paper. And now you can see that if I am suspending this in this direction, you can see that it will move closer to the plastic straw which was charged. So that means it can attract this another plastic straw. So here what happens actually, a plastic straw that charged by rubbing with paper, that will attract, because this is not charged now, suspended charge, this plastic straw. And a plastic straw charged by rubbing with paper repels a suspended plastic charged by rubbing with paper. So if you have this two straw, already this two straw, you are just rubbing it with the paper. At that time, both of them, they are charged. Both of them, they are charged. At that time, you can see that they will repel. At that time, there will be some repulsion. And in this case, there is an attraction. Right? Now the gravitational force, and this is the main thing why we are standing in on
Gravitational force. So gravitational force is the force exerted by the earth on all objects. So that's why we are standing on this earth surface due to the gravitational force. And it pulls all the objects. That's why the apples from the plant tree that will fall on the surface of the earth. So a coin or pen falls down when it slips off your hand. A ball thrown upward falls down. Leaves and fruits fall to the ground when they get detached from the plant, and water in the rivers also flow downward. So the gravitational force, this is the main force why it will attract all the elements or all the objects whatever you have on your surface of the earth. Okay, so this is the gravitational force, and that much for today. Thank you, and thank you all.